A while since we last saw each other. We're fully enclosed now and we're almost ready to start drywall. We've recently installed the insulation, and we installed what's called a wet blown insulation. The wet blown insulation has an adhesive in it that allows it to set up so that it stays in place. And but one of the properties is that it contains a lot of water in it. And so we have to get the water out of it before we can install the drywall to avoid having mold problems. What you see in the background here is one of two large dehumidifiers, and they've been operating for about a week now. They'll probably go for another week before we've gotten the water levels low enough to be able to start drywall. We'll show you around the various rooms. As we were really fortunate, I think, to be able to capture the views that we wanted to get with the windows, the placement. It worked out, I think, better than we had hoped, and so we're very fortunate with that. One of the things that we found with the dehumidifiers, we got the heat turned on, and we'll give you a tour of the heating plant, but we actually haven't needed to turn the heat on. The dehumidifiers are really air conditioners. And the cooling coils attract the moisture to them. They condense in the cooling coils, and then we pump it out into one of the drains. And but the compressors get very hot, and the heat from the compressors is more than enough to get the temperature in here up to almost 80 degrees. So all the money that we've invested in the heat pump system in this house has been for naught so far. With the insulation levels that we have in the house and the quality of the windows that we have, we really have not needed it. So just the heat from the motors for these two units has been more than enough to heat this 2,000 square foot home plus a 900 square foot basement. The thermal resistance values that we've achieved in this house are as follows. In the attic space, we have 2 feet of cellulose insulation. It is new wool insulation, and it is provides an R value of 90. The side walls, we have 10 inches of new wool wet blown insulation, and on the outside of that we have 4 inches of expanded polystyrene, which is a dense polystyrene, and that provides an R value of about 60, 58 roughly. Under the slabs we have about between 6 and 8 inches depending on the area and the heat loss that we would anticipate, which provides roughly an R value of about 30. The windows have an R value of about 9, and that's an aggregate R value that includes the frame and the glass area. Probably the weakest area would be the door system, and that's a standard entry door. We will be putting storm doors on them to enhance the thermal performance, but to go with the really high performing doors was a budget breaker for us, so we opted to go with a lower performing door for the entry systems. So we designed what's called an attic truss, and the floor loads were designed to install a concrete floor over the top of it so that they could install a radiant floor heating system. We just did not require the space. There could be another 1,000 or 1,200 square feet of space in here, but if any future user ever wants to do it, it's here, it's ready to go. They just need to get some light, some windows in here, insulate it. The accommodation to bring future wiring is already in here. It's tied into the smoke detection system. It's all set, ready to go, and we just wanted to make that available to the next user. This is one of the great challenges that we've had on this project, and that is designing space for the distribution system for the radiant floor heating system. We kind of designed this on the fly, so this is the end result of it. But inside of this closet we have 3 of the 5 manifolds for distributing the piping for the underfloor radiant heating system. We'll show you more of the heating system a little bit later. This one is called a hygrometer. It measures relative humidity. This one happens to do a number of other functions, but we're measuring the relative humidity in the room. And then also with this probe, we're able to stick it back into the wall cavity to measure the humidity levels inside of the insulation to see what the state is. We were a week ago, we were at about 80% just in the room, and right now we're hovering right around 40%. So we're making progress, nowhere near fast enough obviously to suit me, but because we're really anxious to get started on the drywall. Right now it's 71 degrees in here. We want to keep it between 71 and 75 degrees. We measured the temperature at the outside wall yesterday, and that was inside the stud cavity, and it was 65 degrees. So a 5-degree temperature differential in 10 inches from at the sheathing on the outside to the inside wall we felt pretty good about. But still, the moisture content at that point was still pretty high. It was in the 70 to 80% range. This takes a minute for the probe to register the moisture content back there. This is just one of many samples that we've taken. And it seems to be hovering around 73%. This is down a little bit from yesterday. It was closer to 80% yesterday. So it's coming down slowly. And you can see we had that in there about this depth, almost 10 inches. And so we were getting a good strong reading way at the back near the sheathing. And now you can see it's slowly recovering to the ambient moisture content, or the relative humidity of the room. The plumbing, heating, and electrical work have been done, and and have all been inspected. And now that the installation is in, we're just about ready for the drywall. As I mentioned earlier, we're looking to dry out the insulation. One of the problems we've had with the insulation, and this was the first wall that they did, is with the settling. And if you look at the top of the wall here, you can see that it's settled a couple of inches. They're going to come and fill that back in before we start the drywall. And they've been working on that, trying to get that fixed. But the intent is that as it dries out, that won't happen anymore. I wanted to point out one of the features that we've done. The building envelope, the integrity of the building envelope, to be sure that there's no leakage, has been vitally important to us. And one of the things that we've done is to install these outlet boxes that have a gasketed seal around them. So when the drywall is installed and fitted to this box, it will seal against the drywall. A couple of days ago, we had the LEED service provider for the area come in and test the building. From earlier pictures, you saw that we had been taping the joints on the perimeter sheathing, and we installed a plywood lid on the underside of all of the roof trusses, and we taped all of the joints. So we had a building envelope that was completely sealed, and we spent a tremendous amount of time and detail making sure that all of the perimeter was well sealed. The LEED provider brought out some equipment to measure what's called the number of air changes per hour using what's called a blower door test. And they put a canvas frame in a door opening, and The canvas frame has a fan in it which is hooked up to a computer, and the computer measures the air pressure outside the door and inside the door, and it can calculate the air pressure differential between the inside and the outside. And by doing that calculation, it can determine how much air infiltration there is. Energy Star recently published a new guideline for high-performing homes of 3 air changes per hour. Passive House, which is the design standard that we chose to, the German design standard that we chose to follow, has a maximum allowable in order to certify of 0.6 air changes per hour. We measured 0.26 air changes per hour, and that's before we have implemented all of the ceiling measures that we wanted to do. So we were really extremely pleased with the outcome, and in fact I've been after my heating and cooling contractors to be sure to get the outside air exchanger complete, because if we don't have that in, we're all going to suffocate. That's a little bit of a joke, but at some point we do need air exchanges in the building, frequent air exchanges. We're just about done with the drywall. We have a few different types of drywall in here. We used a little thicker drywall than is normal because we used studs on 2-foot centers. So we used 5/8 inch thick drywall. And the bulk of the house is just standard drywall, 5/8 inch thick drywall. We used in a couple of areas, the garage and the basement, MR drywall, which stands for moisture resistant drywall. It has a green colored paper on it, and it's designed to withstand high moisture conditions for extended periods of time. Though we're not anticipating problems with moisture in those areas, it's just kind of an additional safety factor. In the bathrooms and in the laundry room, we used a moisture-resistant drywall, called a paperless drywall, and it looks like normal drywall, except that the back of it is a yellow color, and the facing on it is made with fiberglass instead of paper. Mold will grow under conditions where there's moisture and food, and paper is a food source for mold. And so by using fiberglass as a backing material for the drywall, there's no food source, so there won't be any potential for mold growth. And in particular in bathrooms and areas where there is a high moisture content,